Lottery. Players win a large prize when they pick 4 digits that match in the correct order. 4 digits are selected by random, and a smaller prize is won if 3 digits are matched. What is the probability that a player wins the large prize? Okay, so first thing, how many different ways? How many different ways are there for me to arrange these 4 digit number? Well, from the product rule, what we've learned from the product rule here, and that I'm going to apply here. From the product rule, this could be considered as task 1. Task 1 is basically selecting a digit, selecting the first digit. Task 2 is selecting the second digit. Task 3 is selecting the third digit. And task 4 is selecting the fourth digit. If there are n1 different ways to select task 1, and there are n2 different ways to select task 2, there are n3 different ways to select task 3, and there are n4 different ways to select task 4. In total, there are n1 times n2 times n3 times n4 for this entire process. Different ways for the entire process to be arranged. Okay, so for the first digit over here, we have 10 digits. So there are 10 different ways to select the first digit over here. There are likewise 10 different ways to select the second digit, 10 different ways to select the third digit, and 10 different ways to select the fourth digit, which means that I have over here 10 to the power 4, where I am taking 10 times 10 times 10 equals to 10 to the power 4 different ways to arrange these 4-digit numbers. Now the question is, what is the probability that a player wins a large prize? So that from this entire space of 10 to the power 4 numbers, there's one of them that happens to be the winning number, and the probability of selecting that winning number from this entire space here is 1 over 10 to the power 4. So this is the probability. That's part A of the answer. So this is part A. Part B here is, what is the probability that a player wins the smaller prize? So as per the definition, the smaller prize is something where you basically have 3 digits that get matched here. So again, I've got my 4 digits, 1, 2, 3, and 4, and let's just select some winning number. So let's assume the winning number is 1, 6, 2, 7. Okay, so given this number 1, 6, 2, 7, I need to find a probability that a player actually wins the smaller prize. And to win the smaller prize, 3 of the digits must get matched. So let's assume that the person selects 1 over here, 6 over here, and 2 over there. And in this fourth block over here, I can either select 9 digits. This is because if I were to select 7 there, if I were to put 7 there, that would end up winning the larger prize. I want the probability that a player wins only the smaller prize. So the number or the digit 7 cannot be inserted in this blue box. I can insert in there any number that happens to be 1, 2, 3, 4, 5, 6. No 7, 8, and 9. And these are 1, and of course the digit 0 as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 possible digits that can be inserted in this fourth block here. So there are 9 different ways to select the fourth block, and there are 4 different ways. There are 4 different ways to arrange that block, because I could have something like this. I could have something like 1, 6, and here is where I actually have one of the incorrect numbers followed by 7. This could be one possibility, and there are 9 different ways. There are 9 different ways to select the third box over here, and likewise you can see that there are 9 different ways to select the second digit, and there are 9 different ways to select the first digit over here. So there is 9 to the power 4. Sorry, this is 9 times 4, which is 36. Okay, so this entire as per the counting problem, what I'm doing over here is I'm applying the sum rule. So this gives you 9 different ways to select the fourth digit. This gives you 9 different ways to select the third digit. This gives you 9 different ways to select the second digit, and this gives you 9 different ways to select the first digit over here. Now we're going to apply the sum rule, and when you apply the sum rule, it's going to be 9 times 4, which is 36, or basically it's 9 plus 9 plus 9 plus 9. That gives you 36, and I've got a total of 10 to the power 4 different ways to arrange these numbers, which gives you 36 over this gives you the probability that the player wins the smaller prize.